Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at Pure Math 3, Further Algebra, Part 5, Partial Fractions, the Quadratic and Improper part of this. Now, in Part 4, in case you missed it and need to go back and review, we looked at simple and repeated factors in the denominator. So what we're talking about here is we have a fraction that's complicated and we want to break it down into simpler fractions. So instead of adding two fractions together, we're splitting a fraction apart into separate fractions. So what we're looking for is on the bottom, if the factor is linear with an exponent understood 1, then we consider it a simple factor in the denominator. We looked at that in Part 4. If it is linear, again with exponent understood 1, but there's a square on the outside of the factor, then that means there are two of those factors, and it's said to have been a repeated factor. So again, we looked at that also in Part 4. So today we're looking at quadratic and improper. A quadratic factor has a square directly on the variable, and so we're going to deal with that. And also, the first question that we need to always ask ourselves at the beginning is to first make sure that we're not dealing with an improper fraction, because if we are, we have to deal with that first. So what question we want to ask ourselves, we want to look at the highest exponent in the numerator in its polynomial form and the highest exponent in the denominator in its polynomial form. Now, that doesn't mean you have to multiply out all the factors in the denominator. All you need to do is keep track of the x. So here is an x squared, here is an x squared. I think I missed that in Part 4. I went x squared, x cubed, x to the 4th. But it's x squared, so that's x to the 4th, and x, that would be an x to the 5th in the denominator. So if the numerator exponent is greater than or less or equal to, the exponent in the denominator, then it's considered an improper fraction. So let's go to our first question. I'll let you look at it here in the share screen first. So here you can see the code at the top of what past paper it comes from. It says let f of x equal x squared plus x plus 6 divided by x squared times x plus 2 and express it in partial fractions, and it's worth 5 points, meaning you have about 7 minutes to do the problem, okay? So when we look at it, again, the first thing that we want to do is ask, is it an improper fraction? Don't forget to ask that question. So on top we have an x squared, on the bottom we have an x cubed. X squared times x is x cubed. The top is less than the denominator, so we don't have to worry about improper fraction, but always ask that question first. Now we want to look at the factors here in the denominator. We see that this one, x plus 2, is a simple factor, but this one, you might ask the question, how do you know if this is a repeated, as in x with a square on the outside, or is it a quadratic with the square on the x on the inside, because they're both the same? And actually, the answer is you can solve it either way. You can solve it as a repeated, or you can solve it as a quadratic. Since we're talking about quadratic and improper today, we're going to solve it as a quadratic, and then I'll show you at the end how it's the same as the answer you would get if you were solving it as a repeated factor. Okay, so to set this up, we're going to do the simple one first. So a over x plus 2, and then we're going to do the quadratic. Now, again, remember, if the denominator is linear and we don't want an improper fraction, that means the numerator has to be less than the denominator. If it's greater than or equal to, it's improper. We can't have an improper fraction. So if the numerator is less Then linear, that means it's constant. Okay, here's a 1 exponent with an understood 1. That means this is an x with an understood 0, or it cancels out. If this is a quadratic, then that means the numerator can be linear. That means we need to put 2 terms here on the top, bx plus c. Okay, so that's our different questions that we have there. And let me just take a... So what we want to do is we want to solve for these letters, and we're going to eliminate one of these denominators here. So we're going to start with our simple. We're going to multiply everything by x plus 2. Now, like I said in part 4 video, you can do it in your head if you can keep track of things, okay? So if you multiply everything by x plus 2, nothing cancels over here, and I'm just going to write it so you can see it. Some of you might have a little difficulty keeping track of that in your head. And if we multiply this one by x plus 2, notice this is going to cancel. So this is going to go away, and you're just going to have the a there. And when we multiply this one by x plus 2, this one is going to cancel, and all of this over here is still remaining. So try to keep track of what cancels and what doesn't. And we want to plug in a value for x that will cause this to be 0. So if we just solve it, and so x plus 2 equals 0, meaning x equals -2. So if x equals -2, and you plug it in here, this whole thing becomes 0. It cancels out. So -2 plus 2 is 0. 0 times that whole fraction, it's gone. Now remember, this one canceled out, so there's no x plus 2 there anymore. It's just our a equals, and then over here, remember the x plus 2 also canceled out here, and all we have to do is plug in our x equals -2 into this. So x squared would be 4 minus 2 plus 6. We're plugging in a -2 into the x's, divided by -2 squared is 4. Remember, this canceled out. This one is gone, cancels out. So a equals 8 over 4, which equals 2. So that's our first answer, a equals 2. Then we'll get rid of this. Like I said, it's a little faster if you can keep track of it in your head without actually working it all out, because there's a lot of variables that you have to write. But if you need to write it out, please do so. Now if we're going to multiply everything by x squared, so I'll put x squared, that cancels out here. X squared does not cancel out, and x squared will cancel out here. And if we set x squared equal to 0, we get x equals 0. So we plug in x equals 0. Notice this x squared cancels out. And because we're plugging in a 0 for x, it also takes away the b. So what we're actually solving for is the c. Here we plug in a 0, and this whole fraction with the a in it cancels out. And remember, these two already canceled out, so we're putting a 0 in the x's. So that gives us a 6 over 0 plus 2 is 2. So we get a 3 for the c. Now we want to solve for b, but we've already done what we can with the denominators that we have. So when you run out of numbers, then you pick a random number to plug in. 0 is the easiest one, but we've already used it. So if you've already used 0, then go to 1. 1 is also easy to use. So if x equals 1, and what you're going to notice is when you're working with the denominators, like x plus 2, we use -2, and x squared, we use 0. When you're working with those, you're going to get a direct answer for your variable. A equals, there's the answer. C equals, there's your answer. When you have to plug in a random number that doesn't fit with your denominators, then you need to write out the whole equation, but you can plug it in as you go. So if we plug in a 1, 1 squared is 1, plus 1 is 2, plus 6 is 8. 1 times 1 plus 2. 1 plus 2 is 3, times 1 is 3, so we get 8/3 equals. Now we have A, we already know that one, 2, and 1 plus 2 is 3, plus, plug in a 1, we get B, we already know C, and we get a 1 squared, which is 1. So now what we want to do is we want to get rid of our fractions, multiply by 3. 8 equals 2 plus 3b plus 9. 8 equals 11 plus 3b. Negative 3 equals 3b. So we end up with b equals a negative 1. So there's our 3 variables. Now, be careful when you're looking at the mark scheme, because our ABC is 2, 3, and negative 1. It really depends on the order in which you lay this out. I start with simple and work upwards. I do simple, repeated, quadratic, like that. But some people might have put the quadratic first and the simple next. So you're looking to make sure you have a 2, a 3, and a negative 1. The order in which you put these does not matter. What does matter is the final, the way the final fractions turn out. So when we plug this in, we're going to get a 2 over an x plus 2. So make sure that your answer 2, whether it's A, B, or C, is over the x plus 2. And then notice we get a negative 1 on the B. Now that's on the B, it's not on the fraction. So be careful of that. Don't put the negative here. It's on the B, so we get a negative x plus 3 over x squared. And if you wanted to, you could have written this as 2 over x plus 2 minus an x minus 3 over x squared. That would have been fine if you did that. But be careful, because this negative here on the B goes strictly to this term, not the whole fraction. That's a tricky one. Now I want to show you that, and it probably would have been better to write it like this. That way you see your A, B, C, 2, negative 1, and positive 3. If you write it like this, you might get confused because it looks like C is a negative 3, but actually it's a positive 3 because you distribute this negative here. So you do have to be careful with signs, but make sure that you have an appropriate form there. Now, if we break that apart, what I mean is, if we distribute the denominator here, remember division distributes over add and subtract just like multiplication does. So if we distribute that denominator and split that fraction up, then we're going to end up with a 2 over x plus 2 and a minus 1 over x, because the x and one of the x's on the bottom cancel, and then plus a 3 over x squared. So you still get your 2, negative 1, and 3, but now you have 3 fractions. This is what you would have gotten if you had done the repeated method that we learned in part 4, where you have your simple, the x plus 2, and if you viewed this as a repeated instead of a quadratic, then you need to use the x once, and then you need to use the x twice, or to the 1 power and to the square power. So this is actually the same as that. You'll get the same answer whether you treat it as a repeated or as a quadratic. The form will end up a little bit different, but you can see if you distribute the denominator, you will actually get the same thing. My recommendation, even though the reason why I chose to use the quadratic method is because I'm illustrating the quadratic in this video, but if I were to have a choice myself, I probably would have chosen the repeated version of solving it. That way you don't get mixed up with these signs and having to distribute it through that fraction. So it would have been maybe a little bit less tricky, but the amount of work is basically the same. So that's our first one, and let's see what we have next. Okay, let's look at our second problem here. And again, you can see the code up here. It says let f of x equal 2x squared plus x plus 8 divided by a 2x minus 1 times an x squared plus 2, and express it in partial fractions. Again, it's 5 points. So I come back to the board. I want to first ask our question about whether or not it's proper or improper fraction. And so we look at the top, it's x squared. We look at the bottom, x squared times x is x cubed. So the top is less than the bottom, we're okay. Don't forget to ask the question. Every time someone forgets to ask the question, they end up with an improper fraction and they get it wrong, and I'll show you why when we get to an example of that. This one is not improper. We see that we have an obvious quadratic here, and so we want to again use our quadratic method. Let me remind you again, like I mentioned in part 4, that this problem type is not the end. In other words, the answer is not the end. It is the means to an end. These almost always, I won't say always, but usually come in a two-part question. Part 1 is the partial fractions, and then part 2 takes your answer and applies it in another way, either using integration on it or binomial expansion. So it's very important you get this first part right, because that answer is going to carry over into the follow-up question. So I would rather you spend, these are 5-point questions, you have 7 minutes. I still think you can get through the problem in 5 minutes, but make sure you just take that extra few seconds to make sure you haven't made a simple sign mistake or simple calculation mistake. It's very important because your answer moves forward into the next part of the question. And if you get this wrong, then obviously the follow-up question will be wrong. So get it right the first time. So when we look at this, we have an obvious quadratic. So we're going to start with our simple a over the 2x minus 1. Linear goes to constant. Plus, now we have a quadratic. There's no other way to look at it. It can't be repeated. It's obviously a quadratic. So that means the top can be linear. So bx plus c. So as we start off here, let's get rid of our simple one. So if we multiply by 2x minus 1, nothing cancels here. Multiply by 2x minus 1, this cancels here, leaving the a by itself. And if we put a 2x minus 1 over here, this cancels, and we just have this part over here left. So if we solve that, set it equal to 0, we get x equals 1/2. Don't worry about the fraction. Your calculator can help you. So if x equals 1/2, then a will equal. So notice if we put 1/2 in here, 1/2 of 2 is 1. 1 minus 1 is 0. 0 times this whole fraction is 0. It goes away. The 2x minus 1 already canceled out here. All we have is the a by itself. We can solve it directly. And over here, this part is canceled, so we need to do this. So we have a 2 times 1/2 squared is 1/4 plus 1/2 plus 8 all over, again, remember this one is gone, canceled out. So we have a 1/4 plus 2. And when you solve this, the a equals 1 or 2 times 1/4 plus 1/2 plus 8 all over 1/4 plus 2. The answer to this comes out to 4. So you can check that out and do that on your calculator. You get 4. So that's our answer for A. Now, when we move on to B, let's get rid of these. Like I say, it's a little bit faster if you can do it in your head, but it's safer to write it down if you practice it and can't remember. So now we want to multiply by x squared plus 2. Well, we're going to run into a problem. We'll have x squared plus 2 here, cancels out. That looks good. X squared plus 2 here, and x squared plus 2 here, and it cancels out. However, when we go to solve it, x squared plus 2 equals 0, we're going to get x squared equals a -2. And you can't square root a -2. You get an imaginary number. So in other words, there's not a value that can be plugged into this to cancel things out like we did with this one. So this was what's called an irreducible factor. It doesn't actually have a real solution to it. Both solutions are actually imaginary, and we're not dealing with complex numbers right now. So you should be able to recognize that right away. Anytime you have an x squared plus something, it's going to be irreducible. So in this case, we're going to need 2 random numbers instead of just 1. We need 2 random numbers. So the first one, that's to me the obvious choice, is 0, if x equals 0. But since it's random, we're not going to be able to solve directly. We're going to have to plug it in. So when we plug in 0, we get 0, 0, 8. 8 over, we plug in 0 here, we have a -1 times 0, so that means a 2 equals. Here we have a, we know a, 4 over, and when we plug in a 0, we get -1. Plus, when we plug in a 0 here, the b cancels out, so we just end up with c over 0 plus 2 is 2. Okay, so the b canceled out, and we have this 8 over -2, which is -4, equals, here's another -4, plus c over 2. We multiply it by 2, we get -8 equals -8 plus c. And when we add 8 to both sides, c equals 0. Now, if you remember in video number 4, the part 4, I did mention that it is possible to get a 0 for a variable. And this is one case where our c does end up to be 0. So if you get a 0, don't feel like, oh, I did something wrong. It is a possible value that your variable can take. So we end up with a 0 for c, and we pick another number, and of course, if we've already used 0, we're going to use 1. Zeros and ones are very friendly for math operations. So we plug in a 1 here, and we get 2 plus 1 plus 8 all over 1. So it's 2 minus 1 is 1 times 1 squared 1 is 3. So we have 11 over 3 equals, we already know a, 4 over, and we're plugging in a 1. So 2 minus 1 is 1, plus our b, 1 times b is b, and we have a plus 0, so we don't have the c anymore, all over 1 squared plus 2, 1 plus 2 is 3. So now we want to multiply this by 3. So the 3 cancels here. That just leaves us with the 11. 8, 9, 10, 11 equals 3 times 4 is 12. And the 3's cancel and we get B. So our B equals a -1. So we have 4, 0, and -1. Again, when you're looking at the mark schemes, don't let it shock you if your A, B, and C are in different orders. It has to do with the order that they set it up. Just make sure that the numbers fit the equation correctly. So we would have an A is 4 over 2x minus 1 plus, or actually minus, since the C is 0, that minus will affect the whole fraction there, minus x over x squared plus 2. So we have a 4 over 2x minus 1 minus an x over x squared plus 2. This is our answer to this up here. In other words, we've done partial fractions. We took this big complicated fraction, we broke it down into these smaller, simpler fractions, and it will make it easier to do the follow-up question. So in actually part 6, we'll look at the binomial expansion, which then continues on with this, and then later in a different unit, we'll look at integration, where we come back and integrate some of these as well. So that was that one. Let's set up for the next example. Okay, let's look at our next problem here, see what we have. Again, the code is up here if you're interested in that. Let f of x equals 4x squared plus 9x minus 8 divided by x plus 2 times 2x minus 1. Express f of x in the form, and notice it's in partial fractions, except they set it up for you, a plus b over x plus 2 plus c over 2x minus 1. And this one's only worth 4 points because I already set it up for you. Now let's go back to the board. And you'll notice that there's something a little different here. You'll recognize that x plus 2 is a simple factor, and you have, since this is linear, you have a constant on top. And you recognize 2x minus 1 is also a simple factor, and it's linear, and so you have a constant on top. And so you recognize this part here, but why is there this a in front? Well, that's part of why they set it up for you, is to get you to recognize this is actually an improper fraction. What you should do is remember you want to compare. Here we have a 4x squared on the top, and it is divided by a 2x squared. Okay, a 4x squared and a 2x squared. Now, if you remember in basic math, let's just say you have 4 over 3. You know that this turns into 1 and 1/3. But we don't usually write it that way. We put 1 and 1/3 like this, okay? But this is the same thing. This is 3 over 3 plus 1 over 3, which equals 4 over 3. But we write a mixed number like this, not like this. So what this is it's showing you that A is the whole number value that you get when you change your improper fraction into a mixed number. This is the whole number part, and then this is the fraction part. So that's basically what we're doing here, except with fractions instead of with basic math. And again, I said to make sure you ask this question at the beginning of every partial fractions. Look at the highest exponent on top. Look at what would be the highest exponent on the bottom. When you multiply x by x, you get x squared. And if the top is greater than or equal to the exponent on the bottom, on the denominator, then it is an improper fraction. So we need to take care of that first. What will happen is this: if you do not recognize that as a partial fraction, an improper fraction, and if they did not already set it up for you, you would go, oh, this is simple, simple, and you would have put this. You would have put a over x plus 2 plus b over 2x minus 1, and you would have completely missed the whole number part. Now, what that's going to do is this: you're going to solve it, and you'll actually get the correct values for your b and c, or if you had labeled it a and b, you'll get the right numbers for it. But you'll miss a point on this question because you missed the whole number part. And in the follow-up question, because you're missing a part of your answer, it's going to throw off as you continue on. If you're integrating, it's going to throw off your integration. If you're doing binomial expansion, it's going to throw off some of that. So you're going to end up getting 2 problems wrong instead of just 1. So make sure you always ask the question first: is it improper? Keep asking that question at the beginning. Don't forget. The moment you forget, it's going to be improper fraction. You're still going to get the right answers for those parts, but you'll end up going through this and the next follow-up question, and you'll get it wrong. So be careful. So we check it. Now, to find this in a quick, easy way, to find the value of a, all we have to do is simplify this. We have 4x squared is the highest x, the term with the highest exponent on top. We have a 2x times x, that's a 2x squared. That's the highest term in the bottom. You just simplify that and you get 2. So that's the easy way to find a without doing a lot of work to show it. And so a is 2. Okay, we'll just put that right there. Now we can follow the rest of this just like we did in part 4 with the simple denominators. So if we multiply everything by x plus 2, I'll just put it here so you can see it, x plus 2 and x plus 2. So over here it does not cancel. If we solve x plus 2, we get negative 2. So when we plug in a negative 2 plus 2 is 0. This entire fraction disappears. This one already cancels out, leaving us with b. Here we already have 2, so actually I need to put 2 plus b, we already know that a is 2, equals, and then this side over here. So this one cancels out, this already canceled out, leaving just the b, and a we already know is 2. And on this side of the equal sign, which I'm writing over here, the x plus 2 cancels out, so I just have these right here. Plug in a negative 2, becomes positive 4 times 4 is 16. Negative 2 times 9 is negative 18. Minus 8 equals, this is gone, so you have a negative 4 minus 1 is negative 5. So that gives us 2 plus b equals, this is a negative 2 minus 8 is a negative 10, over negative 5 is 2. Oh, what do you know? It looks like our b equals 0. Do we have a b equals 0 here? Here we have this, and our b equals 2. Oh, that's right. I forgot to put x plus 2 here. Sorry, I multiply everything by x plus 2. I forgot to multiply the a by x plus 2. So when you plug in, it cancels out the a. We don't have this 2 right here. That's my bad. I wasn't watching what I'm doing. Multiply by x plus 2, multiply by x plus 2, multiply by x plus 2, x plus 2. So this becomes 0, that becomes 0. We have b here, And so we don't get b equals 0, we get b equals 2. Negative 10 divided by negative 5. So that's our b. A also is 2. That's correct. So we have 2 and we have 2. And now to solve for c, let's erase these. Get rid of this as well so it's not in the way. And now we want to multiply everything by 2x minus 1. 2x minus 1, 2x minus 1, 2x minus 1. I won't forget that one this time. 2x minus 1, and that's going to cancel out this one and leave these. And when you solve this, so if x equals a positive 1/2, when you solve this equal to 0, 2x minus 1 equals 0, 2x equals 1, x equals 1/2. So you plug in 1/2. Remember, this canceled and just leaves you with the c. This one gives you 0, so all that cancels out. This one gives you 0, all that one cancels out. These cancel out, so you're putting a 1/2 in here. 1/2 squared is 1/4 times 4 is 1, plus 9/2 minus 8 all over. This one is gone, 1/2 plus 2. And when we get our c here, we get the this part here. This is 16/2, 11/2 minus 16/2 is a negative 5/2 over, this is 4/2, this is 5/2. And so we get a negative 1 for our c. Okay, so you can do it on your calculator and get that. So our final answer, don't forget the a, that's important. So we have a 2 plus, again, a 2 over x plus 2 minus a 1 over 2x minus 1. So this would be our overall answer there for this particular improper fraction. Okay, let's look at one more example that also includes the improper fraction. Okay, let's look at our last example for this video. It says let f of x equal 12x squared plus 4x minus 1 all over x minus 1 times 3x plus 2. Expressed in partial fractions, it's worth 5 points. Up here is the code from Summer 18, paper 31, number 9. And let's go back to the board. Here we have it, set it up. Again, get it into your head, ingrain it into your strategy that as soon as you see a partial fraction, you first check to see if it's improper. When you look at this, you're like, oh, this is simple denominator. You just jump in and you solve it, and you could run into problems. So first we want to check. Here we have a 12x squared on the top, and we have a 3x times an x. That's a 3x squared. Remember, we're looking at not the coefficients, we're looking at the exponents. The exponent on top, if it's greater than or equal to, it's improper. X squared on top, x squared on the bottom. This is an improper fraction, and so you got to be careful. So this is going to be set up as a plus, then that's the whole number part. Then we do the simple part, b over x minus 1 plus c over 3x plus 2. So again, this is very important, not only to the answer to this question, but also as it carries on into the follow-up question that you'll see later. So how do we find this whole number part? Just simplify these front terms is all you have to do. 12x squared divided by 3x squared is a 4. So you get a equals 4. So that's quite easy to do. But notice you don't want to be missing a 4. So it's important to recognize the improper part. Now we're going to multiply everything by x minus 1, x minus 1, x minus 1, x minus 1. And we're going to say if x equals 1, again, whatever makes it 0. So that makes this 0, all cancels out. This already canceled out, leaving us with the b. This becomes 0, knocks out the 4. And over here, remember, these have canceled out, so we just have to put the 1 in here. So we end up with a 12 plus 4 minus 1 all over 3 plus 2 is 5. So that's 15 over 5. So b equals 3. And we already have a. Now we need to find c. So to find c, I'm going to get rid of this, get rid of this, get rid of this, get rid of this. And we're going to multiply everything by 3x plus 2. So, and when you solve it, x will equal a negative 2/3. So when we plug it in here, this actually cancels out already and just gives us the c. This becomes 0, a negative 2/3. The 3's cancel, you get negative 2 plus 2 is 0. Cancels this out, cancels this out. This one cancels this out. And we just have this right here. We put in a negative 2/3. So we have 12 times 4/9. That's a positive 4/9 plus 4 times a negative 2/3 minus 1 all over. Remember, this one's gone. So we have a negative 2/3 minus 1. And all of this, when you work that out on your calculator, you get a value of c that is equal to negative 1. So your c is a negative 1, b is 3, a is 4. So when you write out the whole thing, you have 4 plus 3 over x minus 1 minus a 1 over 3x plus 2. This is your overall answer that's going to carry forward into the next part of, or the follow-up question after this. So this is partial fractions, particularly looking at quadratic and improper. You also see we got a little bit of review with the simple factors here. And again, you can go back to part 4 if you want to see simple and repeated. And we're in the further algebra here. Again, thank you for joining me. Hope to see you again next time.